Question number 6.295. A stationary positive pion disintegrated into a muon and a neutrino. Find the kinetic energy of muon and the energy of neutrino. So basically there was one pion which is disintegrated into two particles. One is muon and another is neutrino, right? So here we have to find out energy for this muon, okay, and energy for this neutrino, right? So look, in this case we can apply two fundamental principles. First one is, initially this pion at rest and it is getting disintegrated into particles having certain amount of kinetic energy, of course. Okay, so we can apply conservation of momentum first of all here. Okay. So it will use conservation of momentum, that is momentum before this process of disintegration and momentum after this process, right? So initially this pion do not have any momentum, so we can put 0 here, right? And it is equals to momentum of this muon plus momentum of this neutrino, right? So from this expression we can establish a relation that if we talk about the magnitude, then magnitude of neutrino is equals to magnitude of momentum of this muon, okay? Second, we can apply conservation of energy principle, right? So energy of this pion will be m pi into c square before this disintegration takes place. After that we can take, it is sum of E mu, energy of muon, plus energy of neutrino, right? Now see, we can represent energy of neutrino as c into momentum of neutrino, and if we take help of equation number 1, then we can rewrite that this energy can be represented as c into momentum of muon, right? So now if we'll merge these two equations 1 and 2, then we may write that m pi into c square minus energy of neutrino, that is E nu, is equals to energy of muon. Now this energy of neutrino can be replaced by this expression. So we can write m pi c square minus c into E mu is equals to E mu, right? Now we can take a square of both sides. Okay, just let's take a square on both sides. Here I must write E mu, not for neutrino. So if you square this equation from both sides, then from this expression we can write m pi square into c to power 4 minus 2 m pi, right, c cube into P mu plus c square into P mu square is equals to E mu square, right? So from this expression we can write that E mu square is equals to c square into P mu square plus m pi square into c to power 4, and definitely we can ignore this term. This amount will be very small, so we can ignore this amount, right? So from here we can find out, one second, don't think we need to ignore this amount. M pi c cube P mu minus c square P mu square is equals to E mu square, right? Okay, from here let's try to calculate value of c square p mu square, right? So we can rearrange this equation. Let me write it once. That is 2m pi into c cube into p mu mod. Now it was our first equation, right? We calculated with the help of conservation of momentum and conservation of energy. Okay. Now we will write expression for energy of muon. Okay, this is our second equation, and then we are writing a separate equation for energy of muon, that is c square into p mu square plus m mu square, okay, into c to power 4, right? Now this is energy equation for this muon, and this is we have got from this conservation of momentum and conservation of energy. Now it will subtract these two equations. Okay, so if we look closely, what we are getting, these two terms will get cancelled out, these two terms will get cancelled out, right? From here we are going to get m pi square minus m mu square into c to power 4 minus 2m pi into c cube into p mu is equals to 0, right? So it will eliminate c square from this entire equation, right? So we can write value of c into p mu, what we exactly want to calculate from there, that c into p mu can be replaced as m pi square minus m mu square divided by 2m pi into c square. Okay, this is our fourth equation, which is the most important part in this case. Okay, so let me just repeat this process as it got a bit complicated. That one pion is getting disintegrated in two parts, one muon and one neutrino. Okay, so first we applied conservation of momentum. From there we have got that momentum of magnitude of momentum of neutrino is equals to momentum of muon. Then we applied conservation of energy, and from there we have got this relation. Okay, and here we have wrote equation for energy of a muon, and from there we calculated what is c into p mu, right? Now we will write the general expression for total energy of this muon. So what is expression for total energy? That is T muon is equals to under root, we already using this equation, that c square p mu square plus mass of muon square into c to power 4 minus mass of muon into c square, right? This is general equation. Now we can substitute value of c into p mu from equation number 4, right? So this equation can be rewritten as p mu is equals to under root m pi square minus m mu square over 2m pi into c square, okay, and whole square of this entire quantity, because this is c p mu, plus m mu square into c to power 4 minus m mu into c square, right? Now see, if we'll open this bracket from here, right, and rearrange this term, so we can write this term, let me write here, we can write T mu is equals to under root m pi square minus m mu square whole square upon 4m pi square into c to power 4 for this term plus m mu square into c to power 4, all these quantities are in under root, and then minus m mu into c square. Right. Now, if you just multiply by this term in this expression and then open this bracket, okay, let's see what we are getting. Let me do it here. I am just considering this term which is in under root. So we can see from here we can write m pi to power 4 plus m mu to power 4, right, minus 2m pi square into m mu square, okay, c to power 4 we are taking out, okay, plus 4 m pi square into m mu square total into c to power 4. Okay, and in denominator definitely we are getting 4m pi square. Now see, this is simple expression of a square plus b square minus 2ab plus 4ab. So from there we will get a plus b whole square. Right. So we can write this term as m pi square plus m mu square whole square divided by 4m pi square into c to power 4. This entire bracket in under root. Okay. So this under root can be rewritten as p mu is equals to under root m pi plus m mu square whole square divided by 4m pi square into c to power 4 minus outside of this under root mu into c square. Now if we just perform root here, so we'll get p mu is equals to m pi square plus m mu square upon 4m pi square and into c square, or we can simply write into mu, or this is 2m pi, pardon, and into c square, right. Now again, if we multiply this term here, okay, so again we can make I square m, we can use same formula, okay, that is m pi square plus m mu square minus 2m pi m mu, okay, that is m pi minus mu whole square, right. So tu will become m pi minus mu whole square upon 2m pi into c square. This is final expression for the total energy, right. Now see, from there we can write that we already know m pi into c square is 139.6 MeV and m mu into c square is 105.7 MeV. Okay, so here all terms are known, right. We can just multiply by c square in numerator and denominator and take this term inside, right. So okay, let me write here, then m pi c square minus m mu c square whole square divided by 2m pi c square. Okay, these values are known. M pi into c square is 139.6 MeV and m mu into c square is 105.7 MeV. Now we can substitute here, and after calculation we'll get the total energy of muon is equals to 4.12 MeV. Okay. Now similarly, as we have the relation for this m pi c square is equals to E mu plus EV. Okay, so from here we can calculate energy of neutrino as well using this equation, and from there we'll get 29.8 MeV. Okay. Or you can simply write that the way we perform this calculation in similar fashion, we can write an expression for neutrino's total energy. It must be T nu, that T nu is equals to m pi c square minus m nu c square whole square upon 2 m pi c square, and from there we will get this answer.